By the way, just fun fact, I first saw this when I was a student at UC Berkeley over 2 decades ago. Somebody wrote this on the wall in a math building, and then they just crossed it out and then put 1/6, and then so whoa, I was so amazed by it. But anyways, is there a way to find out what other fractions the wrong method works in? I know 26/65 is one of them. Okay, let's have a look. Notice for the fraction 26/65, if you want to simplify it, the 6 is in common, let's just get rid of it. And we see that we get 2/5. And in fact, that's indeed correct. However, this method does not work all the time because if you take a look at this example, 23/35 instead, if you get rid of this 3, do we really get 2/5? No. By the way, how do we check if two fractions are equal to each other though? Here's how we can do it. 26/65, if that's equal to 2/5, just cross multiply. 5 times 26, that's 130. 2 times 65, that's also 130. So this is indeed correct. But if you look at 23/35, is that equal to 2/5? Well, 23 times 5 is 115. 2 times 35, that's 70. So they are not equal. So that means this is definitely a no-go. The truth is, there are so many fractions that this kind of things can happen. We can just call them lucky fractions. In this video, let's go ahead and find out all the 2-digit over 2-digit lucky fractions. Right? So what we want is a fraction that looks like this, AB over BC, and then we want to cancel out the B, and we end up with A over C. And what I said is, this is just a look of the fraction, because if you want to have a 2-digit number on the top, if you put AB, it really means that we are multiplying A and B. So we are going to write this down legitimately. The goal is A, we want it to be in the 10th place, so that's 10A, and then B is the unit digit, so it's B, and then BC is really 10B plus C. We want this to end up A over C. And of course, if we want to end up with nice looking examples, we will have to make sure that A, B, and C are digits from 1 to 9. We don't want zeros and no fractions. And yeah, we will just go from there. So this is how we can approach it. Cross multiply. So I'll take C, multiply with that. We get 10AC plus BC. And then take A times this. So we get 10AB plus AC. Notice we have AC here, so perhaps let's subtract AC from both sides. And I will bring this to the other, so minus BC. And we see that is going to be 9AC. Right here, we have B in common, so we can factor that out. And we get 10A minus C. Then we can divide both sides by this, so we can isolate the B. B is equal to 9AC over 10A minus C. Alright, so we did some work. Now, as you can see, B is going to be depending on A and C. And now we can just choose some nice numbers for A and C. And we have to make sure that B ends up to be a single digit number from 1 to 9. So here's an example that I came up with. If you take A equals 1, the bottom right here is 10. One easy way to make sure that this turns out to be a single digit or a whole number is to make C equals 9. But if C is 9, the top will be 9 times 1 times 9, which is 81 over 1. That's 81. So I don't want that. However, if I pick C equal 5, it works wonders. So let me just have that right here. And we get B will be 9 times AC over 10A minus C. On the top, that's 45 over 5, that's just equal to 9. So based on this combination, A is 1, B is 9, and C is 5. If you put it back here, we are looking at this 19 over 95. You can get rid of the 9 and you end up with 1 over 5. This is indeed correct, but don't do this. But anyways, here are all the fractions that will work for the 2-digit situations. So we have 4 of these nice fractions. 16 over 64, this is perhaps the classic one. By the way, just fun fact, in fact, I first saw this when I was a student at UC Berkeley over 2 decades ago. Somebody wrote this on the wall in a math building. I am serious. And then they just crossed it out and then put 1 over 6 and then so whoa, I was so amazed by it. But anyways, and then next one, 19 over 95 and then 26 over 65. And this one, my least favorite because yes, you can cancel the 9 and this is equal to 4 over 8, but it's not reduced to the simplest form, which is just 1/2. But anyways, it works. Okay, fun fact. If you take any of this, such as 16 over 64, yes, we can cancel out the 6, right? But in fact, I can put on more 6, like this. 166 over 664. Guess what? I can still cancel, and then we'll still end up with 1 over 4. If you want, you can put down a lot more 6. Let's put down like, I don't know how many there's 5 of them. So 1, 2, 3, 4, 5. It's hard to say 5 and then try to write 6. But anyways, ready? Cancel. And this is still equal to 1 over 4. They work, but don't do this.